Hello everyone, myself Dr. Ashalata KS. In this session, we are going to discuss maxima and minima, a function of two variables. Maximum value. A function f of x comma y is said to have a maximum value at the point a comma b if there exists a neighborhood of a point a comma b, say a plus h comma b plus k, for small positive or negative values of h and k, such that f of a comma b greater than f of a plus h comma b plus k. That is, f of a comma b, the value of the function f at a comma b is greater than any other value of the function f at all the points in some neighborhood of a comma b. Minimum value. A function f of x comma y is said to have a minimum value at the point a comma b if there exists a neighborhood of a point a comma b, say a plus h comma b plus k, for small positive or negative values of h and k, such that f of a comma b less than f of a plus h comma b plus k. That is, f of a comma b, the value of the function f at a comma b is less than any other value of the function f at all the points in some neighborhood of a comma b. Next, extremum. Extremum is a point which is either maximum or minimum. The value of the function f at an extremum, that is maximum or minimum point, is called extreme value of the function f. In other words, a maximum or minimum value of a function f is called extreme value. Working rule to determine the extreme values of the function f of x comma y. The first step, first of all, find out the partial derivatives fx and fy and equate these to 0. Solve fx equal to 0 and fy equal to 0 simultaneously for x and y. That means in order to find the values of x and y, let a comma b comma a1 comma b1 etc. be the solutions of these equations. In step 3, for each solution in step 2, find the second order partial derivatives, that is fxx, that is nothing but r. We are going to denote that by small r, the mixed partial derivative as s and the fyy as t. Now evaluate these at all stationary points, at all these points, all stationary points, and also compute the corresponding value rt minus s square. Find the value rt minus s square. In step 4, the function will be maximum if rt minus s square is greater than 0 and r is less than 0 at the point a comma b. Then f has a maximum value at a comma b and the point a comma b is a maximum point. Minimum. If rt minus s square is greater than 0 and r is greater than 0 at the point a comma b, then f has minimum value at a comma b. The point a comma b is a minimum point. Saddle point. If rt minus s square is less than 0 at the point a comma b, then f has neither maximum nor minimum. That is, f has no extreme values at a comma b. Such point is called saddle point. Next case, failure case. That means if rt minus s square equal to 0 at that point a comma b, further investigation is to be needed to determine the nature of the function. Important point, the points at which fx equal to fy equal to 0, say a comma b, a1 comma b, that means you are going to find out the values of x and y. No, those values are called stationary points or critical points, and the values of these points are called stationary values or critical values. Now we'll solve the problems. Examine the following function for extreme values. The first problem, 1 minus x square minus y square. So we'll consider this function as f of x comma y. Now differentiate this partially with respect to x and y. So fx is given by minus 2x, fy is given by minus 2y. Now equate these two to 0. Fx equal to 0, fy equal to 0. That means minus 2x equal to 0, which implies x equal to 0, and minus 2y equal to 0. That implies y is also equal to 0. Therefore, the stationary points are 0, stationary point is 0, comma 0. Now, substitute. Find out the second order partial derivatives. That is, r is nothing but differentiate fx again with respect to x, fxx. It's nothing but minus 2. S is 0 and t is minus 2. Now find out rt minus s square. Rt minus s square value is minus 2 of minus 2 minus s value is 0. So you will get plus 4. So plus 4 is a positive value which is greater than 0. And what is r? R is a negative value which is less than 0. So that means rt minus s square is greater than 0 and r is less than 0, means the function has maximum at the stationary point, that is 0, comma 0. And the maximum value is given by, in the given function, what is the given function? It's f of x comma y equal to 1 minus x square minus y square. Here replace x by 0 and y by 0. So what you're going to get? It's nothing but 1. The maximum value of that function is 1. Next problem, we have to find out the extreme values for this function. What is that function? It's x square plus y square. Again the same procedure, follow the same procedure. First of all, find out the partial derivative, first order partial derivative, and equate that to 0. Find out the stationary point. So here the stationary points are 0, comma 0. Now find out the second order partial derivatives, r, s and t. R is 2, S is 0 and T equal to 2. Now RT, find out the value RT minus S square, that is 4, positive value which is greater than 0. And what is the value of R? It is also positive, that is greater than 0. That means the function has minimum at the stationary point 0, comma 0. Now the minimum value is, substitute the value of x as 0 and y as 0 in the given function. What is the given function? X square plus y square. So you got the minimum value as 0. Similarly, the next problem, f of x comma y equal to x into y. So the stationary points are 0, comma 0 and the rt minus s square value is minus 1. So that means it is neither maxima nor minima. So the function at 0, the function at 0, comma 0 is a saddle point.